There are three types of reactions that we will be talking about. And so what we're going to do here is to learn how to distinguish between the different types of reaction before we go into detail on each type of reaction. So the first reaction that we are going to talk about is a precipitation reaction, or this is also known sometimes as an ionic displacement reaction. The second type of reaction that we're going to talk about is acid-base reactions. And the third type of reaction that we will be discussing are oxidation-reduction reactions, also known as redox reactions. Precipitation reactions occur between two aqueous solutions of ionic compounds. So for instance, we might have sodium carbonate, aqueous, and if we add that to a solution of calcium chloride, what will happen is that the ionic compounds will switch partners. So these cations will go with these anions, and these anions will go with these cations. And so what we end up with when that happens is sodium chloride, aqueous, and calcium carbonate. But the interesting thing about calcium carbonate is that it will not dissolve in water. And since it doesn't dissolve in water, it forms a solid at the bottom of the beaker. This is a precipitation reaction because the solid calcium carbonate precipitates out of solution. So we can tell if we have a precipitation reaction or an ionic displacement reaction because, first of all, the reactants are ionic compounds. Secondly, one of the products is a solid. So if those two characteristics show up in your reaction, then you can be pretty sure that you have a precipitation reaction. In an acid-base reaction, we have one compound that contains a hydrogen, let's say HCl, and another compound that is going to accept a hydrogen from that compound. So let's say ammonia, NH3. And when these two things react, what happens is this hydrogen gets donated to the other molecule, the other reactant. And so what we end up with is Cl minus plus NH4 plus. And these are both aqueous compounds. So in an acid-base reaction, you can tell whether it's an acid-base reaction or not because one of the reactants will have lost a hydrogen and the other reactant will have gained a hydrogen. And that will be the only difference between the reactant and the product in both cases. So when you're looking at acid-base reactions, you're looking for the transfer of a hydrogen plus, an H plus, or a proton. If your reaction is neither acid-base nor precipitation, then it is likely to be a redox reaction. An example of a redox reaction would be CH4, methane, plus 2 oxygens goes to form CO2, gas, plus 2 H2O, waters. And these are actually all gases. So if we are explicit and include the state of matter, those are all gases. We'll learn a little bit later how to verify that this is a redox reaction, but for the moment, if your reaction is not precipitation or acid-base, then you're going to assume that it is a redox reaction. Let's practice categorizing these reactions into one of the three categories. So let's start with this first reaction here. We have sodium nitrate plus silver chloride forming silver chloride aqueous and silver nitrate solid. So you'll notice that we have an ionic compound and another ionic compound combined together. And when we do that, we form a solid and another aqueous ionic compound. That's exactly the characteristics that we said define a precipitation reaction. So this is a precipitation reaction. If we look at the next reaction over here, we have this compound here, happens to be acetic acid, and water. And you'll notice that the products are exactly like this, except it's missing this hydrogen. So we took an H plus off and made this anion. So we remove a hydrogen from here, and this product is exactly like water, but it has one extra H plus, so it has a total plus charge, and it has one extra H plus, 2 here, 3 there. So this proton was transferred to the water, and that defines an acid-base reaction. So this is an acid-base reaction. And then finally, we have this reaction, which does not involve ionic compounds. It does end up with a solid, but it's not an ionic solid. So this does not involve ionic compounds. There are no hydrogens involved. No hydrogens are transferred. And so this is a redox reaction.